Hey everyone, hope everybody are doing good. Welcome to homeschool and welcome back to class 9 science. We are with the chapter Force and Newton's laws of motion. In my previous video, I have covered complete theory concepts or theory aspects that you will find in a chapter. Everything is covered in a detailed way. Don't forget to watch that video. After watching that video, come to this video, you will get more clarity on the questions or the problems that I'm going to solve. See, this video is all about solving exercise questions which are there behind the chapter. Okay, so try to listen carefully. Every problem I have written on a board and I'm solving it in a best possible way. You will find the easiest way of solving these problems. Don't forget to watch the video till the end. Okay, so definitely you will get 100% clarity on all the problems that you have in your textbook. Clear? Fine. See here, you need to remember, a few important formulas to solve all these problems. Okay, so the first type of a formula that you must know is very famous, Newton's second law of motion. Okay, so according to Newton's second law of motion, you have a formula F is equal to ma. So force is equal to mass into acceleration. So this is one formula we use everywhere. Okay, so in almost all the problems which are there in your exercise. And the next formula is, conservation of momentum. So we have initial momentum is equal to the final momentum, right? Whatever the momentum of an object is there before collision, that is equal to the momentum of the object after collision, right? So mathematically, we will write that as m1 u1, right, plus m2 u2, which is equal to, it is, mass is anyway constant. So that is m1, okay, m1 v1 plus m2 v2, isn't it? So this is mathematically we represent conservation of momentum. Along with these two formulas, you should know the formulas that you studied in the chapter called motion. Okay, so we have three equations to calculate acceleration, isn't it? So the first one is very famous, s is equal to ut plus half at square. So this, you will get to use this formula, and you can also use the formula v square minus u square is equal to 2as. So these are the two important formulas. You will also use it in this chapter. Okay, so sometimes acceleration will not be given. Some information they will give. First, you need to calculate acceleration. Okay, say for force, you want mass, acceleration, right? Mass, they'll give it in a question. Acceleration, they don't give. So first, with the given information, you must calculate acceleration. Okay, if distance is given, this is the formula you use to calculate acceleration. Okay, so if distance is given and time is given, okay, then you will use this formula. So any one of the formula you can use according to the given information, right? So these are the various formulas that you need to know. Not only that, units of force is very, very important. Mass, you should always take it in. Okay, let me tell you here. Mass should be there in kg always. Okay, so if it is in a gram, you should always convert that into kg. So we all know the conversion, right? 1 kg is equal to 1000 grams. So sometimes they will give mass in grams. So first you need to convert into kg and then use it in a problem. Okay, and then acceleration, what is the unit? It is meter per second square, right? So usually the force, what will be the unit for force? Mass is given in kg and acceleration unit is meter per second square, right? So this kg meter per second square, we will also call it as Newton. We will also call it as Newton. So always you should keep answer of force in what units, guys? You should always keep it in a Newton. Okay, so this is some unit conversion. You have to be very, very careful. Okay, and these are the different formulas we get to use in various problems that you have in your textbook. So this is what the basic knowledge you must have. With this knowledge, let me explain you the problem that is there in your book. You can look at this question, guys. Actually, this is the fifth question from your exercise part. The question says something like this. You have a truck. So a truck starts from rest and rolls down a hill with constant acceleration. Okay, so you actually have a truck and it is rolling down from a hill. So this is a hill. Okay, it was at rest initially, but now it is rolling down a hill with constant acceleration. Okay, it travels 400 meters. So how much distance it has traveled on a hill? It has traveled 400 meters in 20 seconds, guys. Okay, find A first. Okay, there are two things that you need to find here. One is A, the other one is force acting on it. Okay, so first let us find A. It's very simple. Okay, so how do you find A here? Actually, distance is given. S is given how much? 400 meters. Time is given how much? 20 seconds, isn't it? And then what else is given? Initial velocity. See, truck starts from rest. That means initial velocity is equal to 0 meter per second, right? Rolls down a hill with constant A. So which is the suitable formula that you can use? Final velocity we don't know, right? So we need to find A first. S is given, time is given. So the best formula that you can find A, the best formula that you can select to find A is S is equal to UT plus half AT square, right? So distance is given how much? 400 meters. So U is given how much? 0 into time is how much? Time is 20 seconds plus half into A we don't know, we have to calculate. A into time is how much? 20. So 20 square, right? So it is 400 is equal to 0 into 20 is 0 plus half into A into 20 square is how much? It is 400, right? So ones are 200. So it will be 400 is equal to 0 plus 200A. Okay, fine. So now this A you want to find. So this 200, if it goes to this side, it will go it in a denominator, right? So 400 divided by 200 is equal to A. So ones are, twos are. So A is equal to 2 meter per second square. So this is your acceleration, isn't it? So first part of a question we have finished. Find A, they ask you. With the help of this formula, you found A. Now what you should find? You should also find the force acting on it. So how much is the force that acted on this truck when it was rolling down the hill? Okay, so what is the formula for force? F is equal to ma. So what is the mass of a truck that you have? Is mass given? Yes, mass of a truck is given, that is 7 tons. Okay, so 7 tons, guys. And here, let me erase this diagram. 1 ton is equal to, okay, it is 1000 kg. So 7 ton is equal to 7000 kg, right? So I told you mass you should always take it in a kg. It is given in a ton. We converted ton into kg. Sometimes it will be given in grams. So when it is given in grams, you should convert that into kg. So it is mass is 7000 into acceleration. Just now we calculated how much? 2, isn't it? So force is equal to how much? 14,000 kg meter per second square. So kg meter per second square, you can also call it as newtons, right? So how much is the force? that acted upon truck to roll down the hill, it is 14,000 newtons. Clear? So this is how you have to calculate the problem. So this is actually much simple problem. Fine. And let's go for the next problem here. Look at the next problem, that is, I'm talking about sixth problem that is there in your exercise part. If you can read the question, a stone of 1 kg is thrown with velocity 20 meter per second on freezing surface. Okay, so you have a stone, its mass is 1 kg guys, and with how much velocity you are throwing it? You are throwing it with 20 meter per second. So this is actually initial velocity, right? So where are you throwing this? You are throwing it on a frozen ice. Okay, fine. And this particular stone, when you have thrown with this much velocity onto a frozen surface, it came to rest. Okay, so it came to rest after traveling a distance of 50 meters. So distance is how much? Distance is 50 meters. Very good. So what did they ask you to find? What is the force of friction between the stone and ice? So it's like force they are asking. Frictional force. What do you mean by frictional force? It is the opposing force. Okay, opposing force is called as frictional force. Even to calculate frictional force, you know the same formula, F is equal to ma only we should use. Okay, so F is equal to ma is the formula you have to use here. Mass is given how much? Mass is equal to 1 kg. So in kg, directly they have given 1 kg. But acceleration we want. What is acceleration here? Acceleration is not given directly in a question. So first what you have to do is find acceleration here. So how do you find acceleration here? What is the formula that you can select? We can select v square minus u square is equal to 2as, isn't it? So v is a final velocity. Final velocity is how much? It's actually 0, because once you have thrown a ball, they said it came at rest. So final velocity is 0. Initial velocity is 20 meter per second, right? Distance is 50 meters. So v square is 0 square minus u square is 20 square is equal to 2 into a is what we have to find. Into distance is how much? Distance is 50 meters. Right? So now how do you calculate? Minus 20 square is 400. 400 is equal to a into 2 5s are 10, right? So it is 10. So a is equal to minus 400 divided by 100 if you do. This is 1s are, this is 4s are, right? So minus 4 meter per second square, right? See, acceleration is negative value. You have got a negative acceleration here, right? So now that a value I will substitute in this formula. So if you substitute in a formula, you will get F is equal to m. Mass is 1 kg into a is minus 4. So F is equal to minus 4 Newton. Frictional force is the opposing force, right? So that is the reason you have got a negative value for force. Okay, the force acts in a opposite way. So you had got a negative value. So this is what the answer for this question. And now we'll go for the next questions. Coming to seventh problem that you have in your textbook. Question says you have 800 kg engine pulls a train of 5 wagons. So it's very important to understand, guys. You have an engine. You know how a train looks like, right? So first you have engine and there are so many bogies. So here wagons are nothing but bogies. Okay, so this is engine. This engine is connected to 5 wagons, right? So this is 1, 2, 3 and this is 4th bogie and this is our 5th bogie. Okay, and engine's mass is given, it is 8,000 kg. And each bogie has a weight of 2000 kg. Fine. And you know the engine exerts a force of, so the force exerted by engine, okay, force exerted by engine is 40,000 Newton. And the track offers a friction. Okay, so when engine carries all the bogies and goes, with a force of 40,000 Newton, and it's going on a track also offers some friction. Opposing force can be offered by a track also, that we will call it as a friction. So track is offering a friction of around 5,000 Newton. So this is what the given information, and first thing they are asking you to calculate is net accelerating force. I mean the positive force, total positive force they are asking. So this much is the force exerted by engine, and 5,000 Newton is the friction. So how do you calculate the net positive force? So net force, net accelerating force is equal to force offered by engine, okay, minus frictional force. Okay, so that gives you net accelerating force. So what is the force offered by engine? It is 40,000 Newton minus how much is the frictional force? 5,000 Newton. So what is the total force you have? You have 35,000 Newton. Okay, so this is your answer for first question, guys. And coming to second question. So second question is very simple. They are asking what is the acceleration of a train. So you know the force, right? Force is equal to mass into acceleration. Net accelerating force, you know, that is 35,000 is equal to mass of a train. How much is a mass of a train here? Mass of bogies. So you have 5 bogies, right? So how many bogies are there? Yes, 5 bogies are there, and each one is having a mass 2000 kg. So 5 into 2000 into acceleration. So this is what you need to calculate. So it is 35,000 divided by 5 2s are 10, that is 10,000, right? So 35 divided by 10 is 3.5. So 3.5 meter per second square is your acceleration. Okay, so second question is over. Coming to third question. What is the force exerted by first bogie on the second bogie? Okay, here also force they are asking. So what is the formula you will use? F is equal to m into a. So what is the mass here? Okay, mass is nothing but mass of these 4 bogies, because the bogie number 1 is connected to rest of the 4 bogies. So you need to consider the mass of all the 4 bogies. So it is actually 4 into 2000, right, into acceleration. Acceleration just now we calculated 3.5. Okay, so here the force offered by first bogie on the second bogie, that is F is equal to 4 2s are 8,000 into 3.5 you should do, guys. So calculate this and comment your answer in the comment section. Okay, so very simple. Only thing is you need to understand the question. Always try to draw some picture or some simple diagram, and then try to visualize the question, try to understand the question. Then rest of the thing is just thinking what you have to calculate and what formula you have to apply. Okay, so that's all. Let's go for the next problem, that is 11th question, which is there in your exercise pack. So guys, even here it's very important to understand the question. So let me explain the question with the help of a diagram. I always prefer drawing some form of diagram to understand the question. That makes the problem more easier. That makes the problem to understand it in a better way. Okay. So 2 objects of mass 1.5 kg each. So, you know, they are moving in a straight line but in opposite direction. Okay, fine. So this is one object, this is another object. If this object is moving in this direction, this object will move in opposite direction. Each of the object has a mass 1.5 kg. So even the mass of this fellow is 1.5 kg. Okay. The velocity of each object with, they are moving, in the sense they are moving with some velocity, isn't it? So what is the velocity of this object? It is 2.5 meter per second. and the velocity of this object is also 2.5, but here it is minus 2.5. Can you tell me how this has become minus 2.5? Because you see the direction, velocity is a vector quantity. I consider this direction as positive. So for this object, velocity is plus 2.5. Whereas this object, same velocity, moving in opposite direction, no? So the velocity of this object is minus 2.5. Very good. Okay, fine. And they both have collided, it seems. Yes. Okay, so these two objects, this fellow moving in this direction, this fellow moving in the opposite direction. So, they both have collided and they are staying in one place. See, they have collided and during the collision, they stick together. They have stuck together. Okay, so what is V of combined object after collision? What is V of combined object after collision? Okay, say they are asking what is the velocity of combined object after collision, right? See, that means these two objects are actually at rest. They are not at all moving anymore. Okay, so they are not moving anymore, guys. So they are at rest. So you can guess your answer that velocity of the combined object is 0, right? Because they are at rest. Okay, but then we will use the conservation of momentum here. Okay, so first we know according to conservation of momentum, you know what we studied? Momentum before collision. Momentum before collision remains equal to momentum after collision, isn't it? After collision. Okay, so let's see. Momentum before collision. Momentum of this fellow is how much? Okay, so momentum of this is object A, this is object B. Let me take. Okay, so what is the momentum of A? It is 1.5 into velocity. Momentum is what? Momentum is nothing but mass into velocity, right? Momentum is mass into velocity. So momentum of this fellow is 1.5 into 2.5. Okay, plus momentum of B. What is the momentum of B? Mass, that is 1.5 into minus 2.5, isn't it? Right? Very good. So what is this? This is 1.5 into 2.5, positive value. 1.5 into minus 2.5, negative value. So here the momentum before collision is equal to 0. When the momentum before collision was 0, what will be the momentum after collision? It will be 0. Right? It will be 0. Mass cannot be 0. Right? Momentum after collision is also 0. That means mass of the combined object into velocity of a combined object, you had got 0. Mass cannot be 0. Mass is how much? 1.5 plus 1.5, it is 3 kg. Right? So 3 kg into velocity is equal to 0. So here actually velocity of a combined object will become 0. Okay, so this is highly conceptual question. You can answer this question without even solving. Okay, so just if you can understand combined object is at rest, there only you can confirm that object is at rest. That means what velocity it has? The velocity is 0. Okay, so that's a simple way of answering. Clear? And now let us go for the next question. See, this is 13th question from your exercise part. A hockey ball of a mass 200 gram traveling at 10 meter per second velocity. That ball is struck by hockey stick so that it is returning back with velocity this much. Calculate change in momentum. So what do you mean by small p? I used a shortcut here. P in the sense momentum. Okay, so you have a hockey ball. Okay, so this ball has a mass 200 gram. Convert that into kg. So if you want to convert that into kg, you will divide by 1000, right? So 200 gram is nothing but 0.2 kg, right? Okay, so the mass of hockey ball is 0.2 kg. And this was traveling with the speed 10 meter per second. So velocity of a ball is 10 meter per second. And suddenly it got struck by hockey stick. So this is hockey stick. Okay. So it struck by hockey stick and it started moving back. I mean the ball got struck here. the ball started moving back. Okay, the velocity of a ball when it was moving back is 5 meter per second. Okay, so what is the change in momentum they are asking? So first calculate momentum before collision. So the ball collided with stick, no? So before collision, momentum before collision is how much? Momentum before collision. Momentum is equal to mass into velocity, right? So mass of a ball is 200 gram. That means in kg, you have to take it as 0.2 kg into velocity of a ball initially with what it is moving, that is the velocity you need to consider, that is 10. So 0.2 into 10, it is how much, guys? It is 2 kg meter per second. So this is the unit for momentum, right? So this is momentum before collision. Now you calculate momentum after collision. Momentum after collision. The ball collided with stick, no? After that, the ball started moving backwards. Okay, so that momentum, what is the momentum? P is equal to again m into v. So mass of a ball remains same, right? Before collision and after collision. So mass is 0.2 kg. But velocity, with how much velocity it is going back? Okay, it is going back with, the direction you see. The direction has changed. I have to take it as -5 here now. Okay, so what is momentum after collision? It is actually -1 kg meter per second. So this is momentum before collision. This is momentum after collision, right? So they asked you the difference in the momentum. So what is the difference in momentum? It is, what is the momentum before collision? 2. What is the momentum after collision? Difference. Difference in the sense what? Minus of -1, right? So it is 2 plus 1, that is 3. So 3 kg meter per second. So this is the change in momentum. Okay. So hope you are clear with the problem, right? So this is the momentum before collision, momentum after collision, but they are asking what is the difference in the momentum. So difference in the momentum is difference, subtraction you have to do, initial momentum minus final momentum. Hope you are clear why you have got a negative sign here. See, velocity has a direction. This direction I considered as positive. Ball is moving now in opposite direction with this velocity. So velocity becomes a negative. Momentum is negative here. Okay. So this is how you'll have to calculate this problem. And now let's go for the 14th question, which is really very important. Okay, you need to really think what exactly is given and what exactly they are asking you to calculate. See guys, here a bullet of mass 10 grams traveling with velocity 150 meter per second. Okay, so you have a bullet which has got a mass 10 grams. So immediately convert this into kg. So that is 10 divided by 1000 is equal to 0.01 kg. Okay, fine. So this is the bullet with this much kg and it is moving in this direction with a velocity how much, guys? 150 meter per second. Okay, it strikes a wooden block. So you have a wooden block. When it struck a wooden block and it came to rest, the same bullet comes to rest in 0.03 seconds. Okay, calculate the distance of penetration of bullet. Okay, so how much distance it has covered to penetrate into the block. That distance you have to find. Distance in the sense S you have to find. So what is the formula you have to calculate S here? So S is equal to V square minus U square is equal to 2AS you can use, guys. So here what is initial velocity? Initial velocity, it is 150 meter per second. Final velocity, they said the bullet has come to rest the moment it struck, right? So, the final velocity of the bullet is 0. So here, if you know the acceleration, you can calculate s, isn't it? So for that, you need to find acceleration. So what you need to find here? Find a first. So how do you find a here? You can use this formula. V is equal to u plus 80. So V is 0. 0 is equal to u is 150 plus a into t. How much is time, guys? Time they have given, no, 0.03 seconds. Okay, so how do you calculate? So let me, this 150 I'll take it other side, so it becomes minus 150. Minus 150 is equal to 0.03 into a. So minus 150 divided by 0.03 is equal to a. So if I remove this point, 150, two zeros I'll put up divided by 3. So 1s are 5000 is equal to a. So what is your a, guys? A is equal to 5000 meter per second square, right? So that is your acceleration. You know acceleration now. Calculate the distance. So how do you calculate the distance? V square is 0 square minus, what is u here? U is given, no? U is, right? So u is 150. Okay, so this is u, initial velocity of a bullet. 150 square is equal to 2 into acceleration. Just now you calculated, it is 5000 into s, isn't it? So it is actually minus 150 square divided by 2 into minus 5000, right? Actually, you see, minus 150 divided by 0.03, acceleration is minus 5000, minus value is equal to s. So this much if you calculate, you will get your s value. Here actually s value is equal to 2.25 meters. So this much is the distance traveled by bullet. Okay, so distance you found, and again what exactly they are asking you? They are also asking you the force, right? So how do you calculate the force here? So F is equal to ma. F is equal to mass of a bullet is how much? Just now we have calculated, right? 0.01 kg. So 0.01 into acceleration. Acceleration is how much? It is minus 5000 kg. So you can post your answer in the comment section. How much is the value for force? Okay. See guys, coming to 16th question, much easier question actually. An object of mass 100 kg is accelerated uniformly from velocity. There is an object of mass 100 kg. Okay, accelerated uniformly. This is very important. That means you have a uniform acceleration, and it is moving with the initial velocity. What is u here? U is equal to 5 meter per second, and it moved to some distance, and here the final velocity is equal to 8 meter per second. Okay, so it has moved from here to here in how much time? It has moved in 6 seconds. Calculate initial momentum and final momentum. Here P in the sense momentum here. So three things you need to calculate here actually. One is initial momentum, the other one is final momentum, and you should also find the force exerted on the object, okay, by a floor. Okay, so the force exerted by object also you have to calculate. Fine. So first let us find initial momentum. Initial momentum is equal to mass into initial velocity, right? Initial velocity, that is u. So what is the mass here? 100 into initial velocity is 5 meter per second. So what is initial momentum? It is 500 kg meter per second. Units are very, very important, guys. So this is initial momentum that we found. Similarly, find the final momentum. So final momentum is equal to mass into final velocity. What is the final velocity? Mass is 100 into final velocity is 8. So it is 800 kg meter per second. So this is final momentum. Initial velocity, initial momentum is this much. Final momentum is this much. And they are also asking you the force. So whenever they ask you the force, we have a common formula, F is equal to ma. So here mass is given, that is 100 kg, into acceleration is not directly given, but initial, it's a uniform acceleration. See, initial velocity is there, final velocity is there, time is there. So what is the basic formula for acceleration? Final velocity minus initial velocity by time, right? So what is the final velocity? 8 minus what is our initial velocity? 5 divided by time. Time is how much? 6 seconds, right? So you will have 100 into 8 minus 5 is 3, 3 by 6. So 3 ones are, 3 twos are, right? So you have 100 by 2. Your F is equal to 100 by 2. So F is equal to 50 newtons is the answer. Okay. So very simple problem. So coming to the last problem that is there in your NCERT textbook. Very simple. Okay. Not complicated. How much momentum, P in the sense momentum. Okay. So they are actually asking you the momentum. How much momentum will a dumbbell of mass 10 kg transfer to floor if it falls from a height 80 centimeter? Okay, so you have a dumbbell. So this is the dumbbell. Okay, so this dumbbell has a mass, how much? It has got a mass 10 kg. Okay, and actually it is falling on a floor. It is falling on a floor. And what is the height? From how much height it is falling? It's falling from 80 centimeter. Okay. And acceleration, they told you to take acceleration A as 10 meter per second square. Okay. So what is the momentum they are asking you? Okay. So what is the momentum? Momentum P is equal to mass into velocity, right? So mass is given here. Mass is how much? Mass is 10, but you don't know what is velocity, right? Okay, so you know acceleration, but you don't know what is velocity. So how do you calculate velocity? V square minus U square is equal to 2AS. Okay, from this you can find what is that? The velocity, right? So the final velocity, and here initial velocity is 0. So V square, this factor is 0. V square is equal to 2 into acceleration is 10 into what is that? Distance. Distance is 80 centimeter, but you should convert it in meters. Okay. So we know 1 meter is equal to 100 centimeter. So 80 centimeter is how much? It is 80 divided by 100. Right? So this gets cancelled. So you will have your answer as 0.8 meters, right? So it is 0.8 meters. So 2 into 10 into 0.8, V square is equal to 16, right? So V is equal to square root of 16. So V is equal to 4 meter per second is your velocity. Okay. So momentum is equal to mass into velocity, no? So 10 into 4. So what is the value for momentum? 40 kg meter per second. Okay. So this is the value for momentum. So you have to be very careful with conversion. So here distance is given in centimeter, but we want it in meter, right? So don't forget to convert. Okay. So that's all about the different problems that you have in your exercise part. As I promised, I completed this chapter in a successful way. See, this chapter had got 2 parts. One is part 1 completely on concept. So complete concept I have covered in part 1, and part 2 includes the different problems that is there on a chapter. Okay, so I didn't cover the problems which had solutions in the textbook. I have covered the problems which do not have solutions, especially the exercise problems. Okay, so hope this gives you maximum benefit for those who are feeling this chapter difficult. But this is the most easiest chapter, and we'll meet up in the next video with the chapter called gravitation. Okay, so till then, Keep revising, keep watching, and do subscribe our channel to learn the concepts in an easiest way and in a detailed way. Thank you so much.